Hello friend, today we are going to learn the unit second of numerical analysis, and that is the interpolation. In this video lecture, first we are going to start the definition of interpolation. What is meant by interpolation? First we see the description. Assuming the function f of x is a single value function, and continuous function, and that is known as explicity, then the value of f of x corresponding to certain given value of x, say x0, x1, x2 up to the term xn, can easily computate and evaluate. The central problem of numerical analysis is the converse one. Given that the set of tabular value x0, y0, x1, y1 up to the term xn, yn, satisfying the relation y is equal to f of x, where the explicit nature of f of x is not known. It is required to find a simplex function phi of x such that f of x and phi of x agree at the set of tabulated point. Such a process is called interpolation. If phi of x is a polynomial, then the process is called polynomial interpolation, and phi of x is called interpolating polynomial. In general, we have given function and task is to be found value means root of the given equation. When root are given and we find function or polynomial, then that process is called interpolation. Means in general we have given that function and root of the equation are find. When root are given and we find the function, that process is known as interpolation. This is the main definition of, means simple definition of interpolation. Then article first, we find finite difference. What is mean by finite difference? Finite difference. There are three processes of the difference. First is forward difference. Second is backward difference. And third is central difference. Third is central difference. First is forward difference. In forward difference, first we see the definition. If y1, y2 up to the term yn denote a set of value of y and y1 minus y0, y2 minus y1 up to the term yn minus yn minus 1 are called difference of y, denoting this difference by del y0, del y1 up to the term del yn minus 1 respectively. We have del y0 is equal to y1 minus y0, del y1 is equal to y2 minus y1, up to the term del yn n minus 1 is equal to yn minus 1, where del is called forward difference operator. And del y0, del y1 up to the term del yn minus 1 are called first forward difference and the difference of first forward difference called second forward difference, and we do denote it by del square y0, del square y1 up to the last term. And similarly, we define third forward difference, fourth forward difference, that is del cube y0, del raised to the power 4 y0, del square y0 is equal to del y1 minus del y0. Del cube y0 is equal to del square y1 minus del square y0, and del raised to the power 4 y0 is equal to del cube y1 minus del cube y0. Then we see the forward difference table. Forward difference table. In forward difference table, first take the value x, y, del square, del cube, del raised to the power 4, del raised to the power 5, and del raised to the power 6. Put the value of x is x0, x1, x2, x3, x4, x5, x6, and y1, y0, y1, y2, y3, y4, y5, y6. Difference between these two values y0 and y1, that is del y0. Difference between y1 and y2, that is del y1. Difference between y2 y3, that is del y2, and difference between y3 y4, that is y3, and difference between y4 y5, that is del y5. 4, and difference between y5 y6, that is del y5. And then difference of these two, that is del square y0, and difference of these two, that is del square y1. Difference of these two, del square y2, and difference of this, del square y3, and this is del square y4. The next term, the difference of these two is del cube y0, and difference of these two is del cube y1, and difference of these two is del cube y2, and difference of these two is del cube y3. Then del raised to the power 4, difference of these two is del raised to the power 4 y0. Difference of these two is del raised to the power 4 y1, and this is del raised to the power 4 y2. Then again del 5 is difference of these two, del 5 y0, and difference of these two is del 5 y1, and difference of these two is del raised to the power 6 y0. This is the forward difference table. Then second definition is backward difference. Backward difference. In backward difference, first see the definition of this backward difference. The difference y1 minus y0, y2 minus y1 up to the term n minus yn minus 1 are called backward difference, and they are denoted by del y1, del y2 up to the term del yn respectively, so that del y1 is equal to y1 minus y0, del y2 is equal to y2 minus y1, and up to the term del yn, that is equal to yn minus 1. This del is different from forward difference operator. Forward difference operator del is like this, and this is forward operator, and here backward operator of this is backward. A backward of difference operator फॉरवर्ड डिफरेंस ऑपरेटर के अपोजिट है. इसका ये ट्रायंगल है और ये उल्टा ट्रायंगल है. Then where del is called backward difference operator. In similar way, we can define backward difference of the higher order, that is del square y0 del cube y1, like this. Del cube del square y2 is equal to del y2 minus del y1, and del cube y3 is equal to del cube y2 del cube y3 minus del square y3 minus del square y2. Then we see the backward difference table. In backward difference table, first write x, y, first difference operator, second, third, fourth, fifth, sixth. Then write the value of x, that is x0, x1, x2, x3, x4, x5, x6, and value of y, y0, y1, y2, y3, y4, y5, y6, and difference between y0 and y1, difference between these two, that is del y1, and difference between this del y2, del y3, del y4, del y5, and del y6. Then difference between these two is del square y2, del square y3, del square y4, del square y5, and del square y6. And the difference between these two is del cube y2 y3, del cube y3. Difference between these two is del cube y4, del cube y5, and difference between these two is del cube y6. Del raised to the power 4 y4, del raised to the power 4 y5, and del raised to the power 4 y6. Difference between 2, del raised to the power 5 y5, and del raised to the power 5 y6, and difference between these two, del raised to the power 6 y6. In forward difference operator, we see that the value of this is start del की वैल्यू y0 से स्टार्ट होती है, और बैकवर्ड डिफरेंस ऑपरेटर में डेल के बाद y1 से वैल्यू स्टार्ट होती है. तो इस तरह दोनों में डिफरेंस है, बैकवर्ड और फॉरवर्ड. Then the central difference operator. Center difference. The central difference operator del is defined by relation y1 minus y0 is equal to del y1 by 2 and y2 minus y1 is equal to del y3 by 2 up to the term del yn minus 1 is equal to del yn minus 1 upon 2 and central difference table put the value of x, y, del square, del cube, del raised to the power 4, del raised to the power 5, del raised to the power 6. Here value of x is x0, x1, x2, x3, x4, x5, x6, and value of y, y0, y1, y2, y3, y4, y5, y6, and difference between y0 and y1, that is y1 minus y0 is equal to del y1 by 2, and difference between y2 and y1, that is del y3 by 2. Difference between y2 and y3, that is del y5 by 2, means addition of these two numbers. Del y7 by 2, del y9 by 2, and del y11 by 2. And then this is del square y1, difference between these two, del square y1, difference between this del square y2, difference between these two, del square y3, del square y4, and del square y5. Difference between these two is del cube y3 by 2, del cube y5 by 2, del cube y7 by 2, and del cube y9 by 2. And difference between these two is del 4y2, del 4y3, and del 4y4. Difference between these two is del 5y5 by 2, del 5y7 by 2, and difference between these two is del 6y3. This is the central difference table. Thank you.